Good morning, all of you. Come to the live session. Good morning, my dear students. Good morning, all of you. Come to the live session. My name is Lakshmarina. This is Ellen Brand of Chemistry. Today, we are going to discuss about the ethers. So, complete information for the ethers. So, this is required for even those are preparing for the JEE mains examinations, right? Then, as well as advanced JEE advanced examination, JEE advanced examination. Then as well as EAPCET examination, EAPCET examination. So for all these information is required. See, even the KSET, those are preparing KSET examination in the Karnataka, right? So for all these, it is required. Ethers is required. So please subscribe my channel. Subscribe all of you. Subscribe, like, and share it. So please subscribe, like, share those are preparing for EAPCET examination, competitive examinations. So those are preparing for the JEE mains or JEE advanced and EAPCET KSET examinations. Okay. Yes, come to the live session first. So what are the ethers? Ethers nothing but what? So ethers general formula is R bond O bond R. So oxygen, it is attached to the two alkyl groups. Then we call ether it is. So in this, actually, it is like H2O molecule and ethyl alcohol molecule. See, look at alcohols, H2O. So H bond OH, this will be there. Then alcohols, in case if you take R bond OH, like this will be there. See, in the water, two bond pairs are present and two lone pairs are present. Even in the alcohols also, two bond pairs and two lone pairs are present. In case if we take ethers, then even ethers also two bond pairs and two lone pairs are present. See, all these are oxygen atoms are present in between them. So oxygen here, the oxygen here, then that is sp3 hybridization. sp3 hybridization, then V shape we call the V shape or bent shape. Bent shape. Then our angular shape, angular. So we call all these. So V shape anachu, bent shape anachu, angular shape and kuda anachu. Then if you come to that, even in this case also sp3, in this case also sp3. So oxygen, all these three cases are sp3 hybridization and as well as V shape, no doubt at all, V shape. So here, if you come to the bond angle, so here bond angle, what we can expect in, say in the H2O molecule, wherever the sp3 hybridization is there, generally sp3 hybridization, then look at, observe it carefully, sp3 hybridization. So 4 are bond pairs 4 undi, then lone pairs 0 unte, then that we call tetrahedral shape, right? Tetrahedral shape. So at this time, bond angle is 109 degrees, then 28 minutes. So when tetrahedral shape is present. See, so sp3 hybridization, the bond pairs are 4, lone pairs are 0, then at that time bond angle is 109.28 minutes. Then here, in case same sp3 hybridization, then bond pairs are 3, lone pair is 1, then pyramidal shape we call. Pyramidal shape. Say, if you come to there, so bond angle decreases from 109 to 107. 109 నుంచి 107 కి decrease అవుతుంది. The reason is the lone pairs are present. According to valence cell electronic pair theory, when lone pairs are present, lone pairs and bond pairs in between repulsions will be start. Yes, clear, my dear students? Yes. Then if you come to there, then sp3 hybridization, even in this case also, then here 104 degrees we can expect from there. Then here two lone pairs and two bond pairs are present. So bond angle completely decreases, that is V shape. So wherever the V shape is there, then bond angle is 104 degrees. But actually, sir, when the lone pairs and bond pairs are present, right, then here the largest size of the groups are there. The largest size of the groups are there. So 104 or 107 in between, because then largest size of the groups are there, repulsions are takes place in between them. So in between, so 107 ki 104 ki madhyalo bond angle ఉంటుంది, not exact 104. Clear, my dear students? Understand all of you? Yes. So this is about the ethers. So ethers names, if you take, then common names and as well as IUPAC names, if you take. And if you come to the IUPAC name, for example, CH3 bond O, CH3 is there. For ethers, no suffix. Ethers ki suffix undadu, no suffix. Suffix undadu. Suffix use cheyam. Suffix ante end of the name. That is alcohol kaite ol ani, aldehydes kaite al ani, carboxylic acids kaite oic acid ani ela antamu. So దీనికి ethers ki suffix ఏమి ఉండదు. So that then this whatever the alkoxy group is there, alkoxy group. So this is used as a prefix గానే యూజ్ చేస్తాం. ప్రెఫిక్స్ గా యూజ్ చేస్తున్నామంటే రూట్ వర్డ్ కంటే ముందు ప్రెఫిక్స్ యూజ్ చేస్తాం. So what is the root word and all these things? You know that when we are discussing the IUPAC nomenclature. Then prefix ante, so ikkada prefix alkoxy యూజ్ చేస్తాం. alkoxy యూజ్ చేస్తాం. Sir, in case the methyl group and then oxygen is there, then we call it as methoxy. Methoxy ఎప్పుడు అంటున్నామంటే then OCH3 ఉన్నప్పుడు methoxy అంట. సో ethoxy ఎప్పుడు అంటామంటే, సో ethoxy when we call it, so OC2H5 is there, we call it ethoxy. Then the propoxy when we call it, propoxy, then O bond C, then CH3, then CH3 ఇలా ఉన్నా, then bond O, then CH2, bond CH2, bond CH3. This is N propyl, that is isopropyl. So this is isopropyl. Then this is N propyl. So like this. So whatever it may be, this is the name. Actually, this name, when they are writing the both are methyl groups, so one of the alkyl group act as a suffix, one of the alkyl group act as a root word, right? Then, so this is I'm taking as a prefix. So that is the name of prefix is when OCH3 is there, methoxy we call methoxy. Then in this, how many carbons are there? Only one carbon is there. So then we call it as a methane. What we call methane. So then second one, look at, so in case CH3 bond CH2 bond OCH3. Look at from first compound to second compound, what is the difference is there. Say the length of carbon is increased there, then OCH3 is there. Then here also methoxy we call then methoxy. Then this is what we call methoxy, that ethane we call methoxy ethane, right? Then third one, look at, then CH3 bond CH2 bond O CH2, then CH3 is there, then we call it as ethoxy ethane we call ethoxy ethane. So these are the IUPAC names that we call alkoxy alkane. The common name for this is alkoxy alkane. Alkoxy alkane, ethoxy ethane, methoxy methane, methoxy ethane, ethoxy ethane. Like this you can get. Yes, clear, my dear students? So these are the IUPAC names of ethers. Then we have to discuss about the preparation of ethers are main important. Sir, here only two methods of preparation of ethers are there. So two methods of preparation of ethers are there. See, the first method, it is preparation of ethers. In the preparation of ethers, uh, preparation of preparation of ethers, if you take, I told that two preparation methods are there. One is dehydration of alcohols. So another one is that is Williamson's ether synthesis. Dehydration of alcohols and Williamson's ether synthesis. Two alcohols are present. Yes, two preparation methods are present. One is the dehydration of alcohols. Yes, dehydration of alcohols. Sir, what happens in the dehydration of alcohols? So first I'm taking, sir, ethyl alcohol, CH3 bond CH2 bond OH. This is ethyl alcohol. So 2 moles of ethyl alcohol, 2 moles of ethyl alcohol if you take, then ethyl alcohol at 140 degrees Celsius. So 140 degrees Celsius or, sir, in case the 140, 273 catch cheste. So 140, 273 catch cheste. See, look at, so 3 this is, then 7 plus 3, then 11, then 413. So 413 Kelvin temperature and mention chesna. Leda 140 degrees Celsius and mention chesna. So then ether will be formed. Remember, it is very important to you people, my dear students. So temperature ni base cheskoni, sir, product ko change అయిపోతుంది. సార్ 140 డిగ్రీ సెల్సియస్ దగ్గర ఈథర్ ఫామ్ అవుతే 170 డిగ్రీ సెల్సియస్ దగ్గర ఆల్కీన్ ఫామ్ అవుతుంది, అంటే ఎలిమినేషన్ జరుగుతుంది. సే ఇక్కడ ఏం జరుగుతుంది, సో దిస్ రియాక్షన్, సో CH3 బాండ్ CH2 బాండ్ OH, సో దిస్ at this temperature in the presence of concentrated H2SO4 దగ్గర, concentrated H2SO4, then ether will be formed. CH3 bond CH2 bond O, then CH2 bond CH3, like this will be formed, ether. So ether form అవుతూ ఇది dehydrating agent అన్నాం, the dehydration of alcohols అన్నాం. So that is what H2O will be removed from it, my dear students. So what will be removed? H2O will be removed. See, in case ethyl alcohol, again I'm taking CH3 bond, then CH2 bond OH. The same at concentration of H2SO4, at the concentration of H2SO4. Then again, what we are taking, ethyl alcohol only. Ethyl alcohol తీసుకున్నాం at concentration of H2SO4. Sir, 443 Kelvin temperature, nothing but the 170 degree Celsius. ఏదైనా మెన్షన్ చేయొచ్చు. సో 443 అయినా మెన్షన్ చేయొచ్చు ఎగ్జామినేషన్లో, సో 170 degrees అయినా మెన్షన్ చేయొచ్చు. దట్ యూ హ్యావ్ టు రిమెంబర్. See what happens there. Even here also dehydration takes place, there also dehydration takes place. Then in this dehydration, so within the molecule HOH should be eliminated, then H2O will be lost. But ikkada, so 2 molecules ఉన్నాయి, 2 moles of what ethyl alcohol is there. Then in the 2 moles of ethyl alcohol, from the 1 mole of alcohol H, from the other mole of alcohol OH, so like that H2 will be removed from it. See, this is actually, it happens. Even the same reaction, in case if you take aluminum oxide, so aluminum oxide at 250 degrees Celsius. See, look at 2 moles of C2H5OH ethyl alcohol, when it is treated with at 250 degrees Celsius, at low temperature, so ether will be formed, CH3, sir, in the presence of Al2O3. See, concentrated H2SO4 also act as a dehydrating agent. Then Al2O3 also act as a dehydrating agent. So Al2O3 చేసినప్పుడు then CH3, then CH2 bond O, then CH2 bond CH3. So ethoxyethane will be formed. Then CH3 bond, then CH2 bond, then OH if you take. Sir, 100 degrees Celsius, 350 degrees Celsius, 100 degrees Celsius increase చేస్తాయి. 250 నుంచి 350కి ఇంక్రీజ్ చేస్తాయి. సో ఇన్ ద ప్రజెన్స్ ఆఫ్ Al2O3 again, then what will be formed? Same product is CH2 double bond CH2 plus H2O. సో ఇక్కడ H2SO4 కాన్సన్ట్రేటెడ్ H2SO4 యూజ్ చేసినప్పుడు 170 డిగ్రీ సెల్సియస్ దగ్గర అల్కీన్ ఫామ్ అవుతాయి. దెన్ అల్యూమినియం ఆక్సైడ్ యూజ్ చేసినప్పుడు then ethyl alcohol can be converted into ethene by the loss of H2O only. Clear, my dear students? Just note down this equation, then we'll discuss the mechanism. So what is the mechanism that we'll discuss? Yes. See, look at my dear students. So what is the mechanism for the preparation of this? Preparation of ethers. What is the mechanism that we'll discuss? See, mechanism for preparation of ethers, right? So ఏంటి preparation of ethers ఇక్కడ? The 2 moles of CH3 bond CH2 bond OH, the reaction with concentrated H2SO4 at 140 degrees Celsius, then CH3 bond CH2 bond O bond CH2 bond CH3. So what is the name of this compound, man? Ethoxyethane will be formed. Ethoxyethane will be formed. Clear? Understand all of you? Yes. So come to the mechanism first. So what happens? So concentrated H2SO4. So H2SO4 can release as H plus because it is acid. Then HSO4 minus. Then HSO4 minus. It will be formed like this. Say once it is formed as a HSO4 minus, once it is a strong acid, then after the removal of H plus remove అయిన తర్వాత ఫామ్ అయిన anion ఏదైతే ఉందో, so that is act as a weak base. Remember my dear students, ఇది weak base గా పనిచేస్తుంది. క్లియర్? సో ఇందులో ఉన్న H ప్లస్, సార్ ఇందులో ఉన్న ఇథైల్ ఆల్కహాల్, ద ఫస్ట్ స్టెప్ CH3 బాండ్ CH2 బాండ్ OH ఇస్ దేర్. సో ఇందులో లోన్ పెయిర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉంటాయని చెప్పారు. ఈ లోన్ పెయిర్ ఆఫ్ ఎలక్ట్రాన్స్ ఈ H ప్లస్తో రియాక్ట్ అయిపోయి దెన్ CH3 bond CH2 bond O bond H, then bond H on the oxygen atom, positive charge will be formed. Em form avutundi? Positive charge form avutundi. See, look at this bond. Whatever the bond is there in between the carbon and oxygen, whatever the bond is there, that bond will be shifted towards the oxygen. Then H2O molecule will be removed from it. So H2O molecule remove అయిపోయిన తర్వాత CH3 bond CH2 bond పాజిటివ్ చార్జ్ అంటే కార్బోకాటయాన్ ఫామ్ అవుతుంది. సో ఇది ఎప్పుడు రియాక్షన్ జరుగుతుంది అంటే at 440 డిగ్రీ సెల్సియస్ దగ్గర రియాక్షన్ జరుగుతుంది. at 440 డిగ్రీ సెల్సియస్ దగ్గర రియాక్షన్ జరుగుతుంది. బట్ ఇక్కడ సో వన్స్ this is formed, which is CH3 then CH2 bond OH will be formed. So look at CH3 bond CH2 bond then OH positive charge will be formed. Then one more ethyl alcohol CH3 bond CH2 bond OH. Sir, on this lone pair of electrons are there. So wherever the lone pair of electrons are there on the oxygen atom or nitrogen atom, that is act as a nucleophile. So here it is act as a nucleophile. Nucleophile attacks backside of the leaving group. ఏది leaving group ikkada? So this is the leaving group. Observe my dear students, the H2O is the leaving group. సో అది బ్యాక్ సైడ్ ఆఫ్ ది లీవింగ్ గ్రూప్ నుంచి కార్బన్ని అటాక్ చేస్తుంది. సో దట్ వాట్ హ్యాపెన్స్ సో బై ద లాస్ ఆఫ్ H2O లాస్ అవుతూ దెన్ వాట్ విల్ బి ఫార్మ్ సో CH3 CH2O CH3 CH2O then H as usual will be there. So one lone pairs on attached to there, the positive charge will be formed on the oxygen. ఎక్కడ అటాచ్ అవుతుంది? The carbon CH2 then bond CH3 like this will be formed by student. Okay, then I told that HSO4 minus act as a weak base. Then here HSO4 minus ఏం చేస్తా ఉంది? వీక్ బేస్. బేస్ ఏం చేస్తుంది? జనరల్గా H ప్లస్ అయాన్ని అబ్స్ట్రాక్ట్ చేసుకుంటుంది. సో H ప్లస్ అయాన్ ఇక్కడ ఉన్న H ప్లస్ అయాన్ని అబ్స్ట్రాక్ట్ చేసుకుంటుంది. సో దట్ అగైన్ ఇట్ విల్ బి కన్వర్టెడ్ ఇంటూ H2SO4. దెన్ లుక్ ఎట్ ద వాట్ విల్ బి ఫార్మ్ CH3 బాండ్, దెన్ CH2 బాండ్, దెన్ బాండ్ O, దెన్ బాండ్, దెన్ CH3. సో లైక్ దిస్ ఈథర్ విల్ బి ఫార్మ్. ఏం ఫామ్ అవుతుంది? సో ఈథర్ ఫామ్ అవుతుంది. సో దిస్ ఈస్ ద మెకానిజం యాక్చువల్లీ మై డియర్ స్టూడెంట్స్. Sir, observe the mechanism carefully. Yes. Let's look at, so after the mechanism, so we'll see. So one more preparation method. So before going to that preparation method, whatever the mechanism is there, what happens there, that we'll discuss once again. Look at carefully what is happening there. First, mechanism lo CH3 then CH2 then OH, H2SO4 నుంచి H ప్లస్ ని తీసుకుని దెన్ CH3 బాండ్ CH2 బాండ్ O, then H, then H, then positive charge will be formed. So that then next what happened, so one more ethyl alcohol act as a nucleophile CH3 bond CH2 bond OH. This is act as a nucleophile. It is going to attack backside of the leaving group. So that what happens? CH3 bond, then CH2 bond, O bond H, then bond CH2, then bond CH3, then positive charge will be formed. Sir, after that, HSO4 minus, it is act as a weak base I told. Then it will take H plus ion from there. Then H2SO4 will be formed. H2SO4. H2SO4 by reacting with that. Then CH3 bond CH2 bond O bond CH2 bond CH3. ఇలా ఒక ప్రోడక్ట్ ఫామ్ అవుతుంది. ఈ ప్రోడక్టే ఇథాక్సీ ఈథేన్ will be there. Clear, my dear students? Right. So now observe this mechanism carefully. What is happening there? ఈ మెకానిజంని మీరు అబ్జర్వ్ చేస్తే దిస్ మెకానిజం, రిమెంబర్ సమ్ ఆఫ్ ద ఇంపార్టెంట్ పాయింట్స్. దిస్ రియాక్షన్ మెకానిజం SN2 mechanism equal. So why we call the SN2 mechanism? SN2 mechanism. This reaction mechanism is SN2 mechanism. Next, this reaction mechanism, wherever the carbocation is formed. Say, look at this nucleophile attack step. We call it as RDS step. Then one more point you have to remember. In this, actually, wherever the SN2 mechanism is there, so no carbocation formation. Carbocation formation. No carbocation. Carbocation form over. Then next you have to observe one more. This reaction majorly takes place when primary alkyl groups are present. So primary alkyl groups ఉన్నప్పుడే ఇది reaction జరుగుతుంది. Then you have to observe one more thing. So nucleophile attacks backside of the leaving group. Nucleophile attacks backside of leaving group. Okay, so where it is backside of the leaving group, nucleophile, the backside of the leaving group, it will be attached to it, right? Yes, my dear students, these 3 points you have to remember. It's very important points. Then preparation of ethers from the alcohols in the presence of concentrated H2SO4 at 443 Kelvin temperature. That is SN2 reaction mechanism. SN2 reaction mechanism. Then no carbocation is formed in this reaction mechanism. Then third point you have to remember, nucleophile attacks backside of the leaving group. This is first reaction, first preparation method for the ethers. Then second preparation methods is there, that is Williamson's ether synthesis. Yes, please subscribe my channel and share it. Those are preparing for JEE Mains, JEE Advanced, EAPCET examination, KCET examination. Yes, please subscribe my channel, subscribe and share, like it. So those are in the like my channel. Then second one, Williamson's ether synthesis. Williamson's ether synthesis. Williamson's ether synthesis. So what is the Williamson's ether synthesis first? Sir, here sodium alkoxide, when it is treated with alkyl halide to form ether. What I told, sodium alkoxide reaction with alkyl halide. Sir, on heating, so heat చేసిన తర్వాత then look at, so ether will be formed. Ether plus NaX, sodium halide will be formed. See, look at one of the example for this. So CH3 bond O bond Na. See, in this sodium methoxide we call sodium methoxide. Clear, my dear students? Sir, here that is O minus Na plus will be present. It is ionic bond in between them. Plus, when it is treated, so alkyl halide, one of the example for the alkyl halide is CH3 bond Cl, if you take. See, now on heating, what happens? Then NaCl will be eliminated. Then CH3 bond O bond CH3. So ether will be formed. This ether is methoxymethane, right? Methoxymethane. So methoxymethane will be formed. Yes, clear, my dear students? Right. So look, all of you. Then in the sodium methoxide. So OCH3 minus. This is act as a nucleophile as well as base. This is act as nucleophile as well as base ga kuda panchestundi. That is very important, my dear students. Idi nucleophile ga work chestundi, then and as well as then base ga kuda work chestundi. See, if you see the mechanism, so mechanism kanaka meer observe cheste, if you observe, say first we are taking, that is CH3 bond Cl alkyl halide. Then when it is treated with the CH3 O Na. So in this O minus Na plus I told. So this is what I told. It is act as a nucleophile. The negatively charged species act as a nucleophile. Lone pair of electrons containing molecule also act as a nucleophile. So what are the nucleophiles? Lone pairs and as well as then negatively charged species. See, this will be attacked backside of the leaving group. Which is the leaving group, man? So Cl minus is leaving group. Leaving group we call. So it will be attack on the backside of the leaving group. Then what will be formed? So CH3 bond O bond CH3. Then, sir, once if it is removed from it, Cl minus, then Na plus, it will be formed as NaCl in this reaction. Yes. So observe this, ether will be formed. So in this mechanism also, we can say that it is, yeah, look at it is SN2 reaction mechanism. SN2 mechanism. Why we can say the SN2 mechanism? Because nucleophile attacks backside of the leaving group. Nucleophile attacks backside of leaving group. Backside of leaving group. Then third one, that is alkyl halide, whatever we are taking, alkyl halide, that should be primary alkyl halide. Primary alkyl halide. See, wherever the SN2 mechanism is there, then, sir, in case alkyl halides are involved in it, then primary alkyl halides are more predominantly involved in the reaction. Then after secondary alkyl halides, then after tertiary alkyl halides are involved. So that is what primary alkyl halides is. So more reactive in this. Then formation of ethers are good for in case if you use primary alkyl halides. Yeah, some of the point. It is one of the most important point in it that we have to discuss in the Williamson's ether synthesis. The Williamson's ether synthesis. Even a question also you have to discuss in it. A question also we have to discuss in it. Look at what is that. If alkyl halide is primary in Williamson's ether synthesis. Williamson's ether synthesis. Ether synthesis. See, look, my dear students. Primary alkyl halide is primary in the Williamson's ether synthesis. Then predominantly ethers will be formed. Ethers will form. So formation of ethers ki, sir, it is a preferable. Primary is a more preferred. Then if tertiary alkyl halides are used, instead of substitution, elimination takes place. Yes. If One is primary, one is tertiary.